Assalamu alaikum dear friends. Today we are going to study another concept about binary trees and binary search tree. So basically this concept is the binary search tree, that how we form binary search trees, how do we insert elements into a binary search tree, and what is the proper method to use the numbers to insert into a binary search tree. Well, first of all, the concept of binary tree is that any tree that has at most two children, or maybe one child, or maybe no child, that will be called as binary tree. So these are the three types of binary trees. This is a binary tree that has two children. It is a balanced binary tree. This is the binary tree that has just one child, and this is the binary tree that has zero child. So these three are all binary trees. Okay, if you are asked in the exam that you have to create a binary search tree with following keys 4, 2, 3, 6, 5, 7, and 1. So if you are asked to make a binary tree, someone might think that okay, I'm going to make a binary tree out of these keys. So why not I just make a node 4 and randomly put 2 here, randomly put 3 here, maybe I can put 6 here, and then I can put 5 here, and then I can put 7 here, and maybe 1 here. So this is a binary tree because no node has more than 2 children. So this is a binary tree. Okay, fine, this is a binary tree. Similarly, even if I remove 3 from here, I can put 3 here. That is still a binary tree. So what is the right answer to such sort of a thought process? Is it the right binary tree? So my answer will be no. This is not the right way to do a binary tree. Why? For example, you have been asked to search for the key 3. So now how will you search for the key 3? You will have to go on to each and every node. Is this the node key 3? Is this the key 3? So you will be going on to each node and you will be searching for the key 3. Similarly, if you are asked that okay, search for key 2, then you will be going on to each node. So in that case, what will be your order? Your order will be order of n, right? Your order will be order of n. So this is the same order that you follow when you do linear search. So what is the benefit of making this complete concept of binary search tree or binary tree if the search order is again your linear search, and which is a very big time complex order? So this shows that this is not the right way of inserting the keys into a binary tree. Okay, so now let's move on to the right way of search of inserting keys into the binary tree. Once you have got the idea that what is the wrong way of inserting, then I am going to give you the rules. So the rule says that your your left value has always to be smaller than your node that you are considering. The value which you insert onto the left hand side, this side, has to be smaller than the node after which you are inserting the value. For example, the node is x and you are inserting a value y, so y has to be smaller than your node, and your right value has to be larger than your node. So if you are inserting a value z on the right hand side, then this z has to be larger than x. If this z is not larger than x, then you will insert it onto left hand side. So anything that is going on to the right hand side has to be larger. Please do not confuse binary search tree or binary insertion with max heap or min heap, because in max heap or min heap you put the maximum value on the top, right? In max heap you put for example, if you put x on the top, and here is a y and here is z, then x is always larger than y and z, both, right? It is larger than both of them. There is no rule about left value or right value. So please do not confuse this binary search tree and binary insertion with max heap or min heap. This is a different concept and this is a completely different concept, so please be clear about that. Okay, so now after clarifying all the confusions, now we are simply going to draw this binary search tree. So first of all, friends, I'm going to make this node 4. So after 4, which is now my root node, I have to insert 2. So is 2 smaller than 4 or larger than 4? Of course it is smaller, so it will come on to left hand side. So I have written it like here. 3 is also smaller than 4, so I will come on to left hand side, and 3 is not smaller than 2, it is larger than 2, so it will come on right hand side. So basically I am coming on to the left subtree of 4, but I am coming on to the right subtree of 2. Okay, so the next element is 6. So 6 is larger than 4, so I will straight away come on to the this right subtree side. So this is 6. Okay, now then the next term is 5. So 5 is basically larger than 4, so I will come on to the right subtree side, and when I come on 6, so then 6 is of course 6 is larger than 5. 5 is smaller than 6, so on to 6 we will go on to left hand side, so 5 will come here. Okay, next element or the key that we need to insert is 7. So 7 is larger than 4, so we will come on to the right subtree, and we compare 7 with 6. Still 7 is larger, so we will again come on to the right hand side, and it will come on to the right it will become the right subtree of 6. So the last key to be inserted is 1. 1 is smaller than 4, so according to this rule the left values are smaller than node, so it will come on to left side. And if you compare 1 with 2, 1 is even smaller than 2, so it will become left subtree of 2. So basically you have inserted all the given keys, and this is your binary tree. So you can see that it is a balanced binary tree. Now if someone asks you that you have to search for the smallest value 1, you do not have to go on to all the tree, and you do not have to do n iterations. Your order of complexity, your time complexity will not be n. You will simply go on to 1, because remember this rule that your left most node, your leftmost node is your smallest node always, and your right most node will always be your largest element. So you can see that your leftmost node is your largest element, and your rightmost node is your largest element, and your leftmost node is your smallest element. Other than this, another very interesting fact about these binary trees is that if you do in order traversal of this binary tree, you will find out a sorted array. I have taught about in order traversal in my previous video. If you want to see that, you can see that to get the details, but just for your ease I can actually do the in order traversal of this binary tree here. So once we basically what we do in order traversal, in order traversal means that we are traveling through the tree, and we hit onto the node second time. Whenever we hit onto the node second time, we write it down into our in order traversal. So if I start moving from 4, and this is my first visit on 4, so I will not write it down. I come on to 2, and then I come on to 1. So I have to add some dummy children under these nodes which are not having any children, right? So if I have came on 1, and now this, you can see this line is touching 1 second time, because I have visited 1 node 1 time, and now this line is touching 1 second time, so this is my second visit on the node 1. So in order traversal, this node 1 will come at first position. So after this I am coming on to node 1 third time. I will not write it down again. From node 1 I am going back onto node 2. This is my second visit of node 2, so I will write it down here, because rule of thumb is that whenever you visit any node second time, you will write it down. So because I visited node 1 second time, I wrote it down, and now I visited node 2 second time, so I wrote it down. And now from here I am continuing my journey, and I have reached node 3. This is my first visit of node 3, so I'm not going to write it down right now. But yes, after traveling and reaching it second time, I have written it over here. And from here I'm continuing my journey. This is my third hit on node 3. I'm not going to write it down again. From here I have reached my root node once again. This is my second visit, so I will write it here. And from this point I have hit onto node 6. This is my first visit, so I will not write it down. From here I will continue my journey. I'm hitting onto node 5, and now I'm hitting onto node 5 second time, so I'm going to write down 5. And from 5 I'm going to hit on node 6 second time, so I'm going to write it down. And from here I'm going to hit node 7 second time, and I'm writing it down. And from here I'm going back onto 6, and then I'm going back onto 4. I have not written them down because these were my third hit. So now you can see that in this way I have done the in order traversal, and now you can see that all your nodes are in order. What do I mean? That in order of course means that first of all you're getting the smaller node, and in the end you're getting the largest node. So with the help of this perfect mechanism of insertion in binary tree, now you can actually place all your nodes in order, and it is very easy to find out the smallest number, to find out the largest number, and even to find out the middle number, which you can call median. So guys, if you like this description of the binary tree, how it is different from max heap, what is the rule for insertion of keys, then do like and subscribe to the video. And you can ask your questions in the comment section. Thank you very much. Allah Hafiz.